Hey guys, welcome back to my channel. I have an interesting video too, and also for my records and to show the customer that I'm testing his computer. So I want to share, first this is a 2003 Mazda Protege 5, I think. Hopefully I'm saying it right. Um, he sent me the VIN number, but something is not matching correctly. But I was able to, pull out at least a 2003, which is what he said the vehicle was. So his complaint is that the computer, I guess the engine runs good, the car runs good, but as after like 5 minutes or so, start decaying, like running bad until it dies, and then it loses communication with the computer. Um, I asked him to do some motor testings, but he decided to send the computer to me in order to test the module. So this is how the module looks. It's really a Ford computer, even though it's made specifically for Mazda. Let me just turn around so you guys can see the other side as well. And let me put my glasses. Yeah, we can see it's a ECB, which is made by Ford, and they have this on Jaguars and other vehicles. The Ford Lightning uses this module, not populated the same. They use the same 104 pins, but well, you can see right here it says Ford. It's like I said, they populated the module different. That's why some ICs are missing in here, and some of the current resistors are different values, and just the way it is. All right, so to keep on the thing that I want to share with you is I do my homework on every vehicle that I do. I got to go over the harness, the wire diagrams, which in this case are, I mean, a nightmare, but it's just the way it is. So I usually get the powers, the grounds, the communication, which was a little confusing on the harnesses, I mean on the wire diagrams, and you will see, but I figured it out. And then the main signals that I want to at least to test while I have here, because I want to make sure that I keep, a good communication with the computer when I'm doing tests. I'm not sure if I'm going to be using the coils or the injectors, not just yet, but so far what I want to do is use the fuel pump, which is the fuel pump relays, pin 80, and the coolant temperature, pin 38. For this, I'm using my variable and programmable power supply, so you guys can have the part numbers. This signaling is being fantastic. I have no complaints with it. It's very affordable and it's very, very good. You can graph even if you want for power and consumption. I'm also using, this is very, very handy. Uh, it's from this company, EDFM, and I see it's a DK box, but you can do resistance and capacitors, and combine them as well. Depends on what you're working on, and it's really good. It's not cheap for what it is, but it's very well built. So I have no complaints again too. It's a max of 1 watt for resistance and maximum 30 volts for capacitors. All right, so I also got this, which is also really handy to work on testing computers because it has different connectors. It comes with only 2 plugs, so which is plenty. But if you want, you can make your own. It has 6 outputs. The main power, which is connected to the power supply, and it has the LVD port, which is the one I'm connecting via VCI to my Autel Elite, which I have here. I already selected myself the vehicle. I couldn't do um, being reading. Let me just try it once again with you guys. Let's do, I'll scan, see if it reads the PCM. Yes, it reads it. All right, so let me exit here and see if it reads the beam. Because before I was trying to read the beam, and as you can see, I was not able to. So I select all these myself. I just went to Mazda, North America, and then So this is the bean that I think I put, let me see, JM1BJ24. So this one, and that actually, let me stop the video 1 second because that's not going to work. Well, I am connected to the internet, but for some reason I cannot really decode that being. Let's just leave it. I don't think it's going to take that long. Well, in the meantime, I have already rigged just a test light to ground for the fuel pump right here. So pin 80, which is the fuel pump relay control. So it's a ground supplied by the computer. And then a test light connected to battery voltage. Again, positive going into the same variable power supply that I have. And then the pin 38, which is the ECT, coolant temperature sensor. I just got it through a resistor, decay box right here. So we supply the ground. And then I put a 400 ohm resistor resistance to just be around, 160, one something. Well, in this case, actually, I read it. All right, so let's say 2003. Well, so this time I read it though. Perfect, so that works. And it shows us a manual transmission. I might be wrong in there because the B number he gave me, his name is Oscar from Texas. He gave me 7, which I don't think is correct. So, all right, so let's go to diagnosis in here. Then I'm just going to go over to control unit, PCM. PCM stands for Powertrain Control Module. And then I'm going to select the active test. What I'm looking in here is to see if the computer heats up and then it start to, lose the communication. That's what I'm pushing. I'm using the fuel pump relay, which is a load. Obviously, I don't have the coils and injectors. I can only simulate the signals, so I don't have the whole vehicle, obviously. All right, so I'm going to just put in here, I just want to see the battery voltage and the coolant temperature, not RPM, coolant temperature, voltage, and Celsius isn't here. I don't know what it shows us in Celsius, but hopefully that resistor, we can change the value. So it's in 165, so that's perfect. And it's showing 1 volt. So if I change that to, let's say, 500 ohm, you see how it changed now to like a 150. So we can play with that. You can play, going down to 400 and put in like 450, whatever you want to do. And as you can see, the value changes in there. And that's what you're looking for. That's what a small decay backs in there works for simple things that you're looking to do in a computer like this. Obviously, I do have my simulator that I can do everything that I'm doing through there with this. So, but I'm not using it because again, this is just a concern, no communication. So again, don't connect all the signals and everything on a test like this. All right, so let's turn the fuel pump on. Let's just wait for that to say on. I don't think I pressed it. No, I did. And now we got the test light on. All right, so I'm going to turn it off so you guys can see. 1 second, so I'm turning it off now. Takes like 2 seconds to turn off. Okay, and now I'm going to turn it back on. Should be coming on soon now. Okay, perfect. All right, so as we can see, I have full control of the fuel pump relay, and we are reading the temperature correct. So the next thing that I do usually here is use my thermal camera, which in this case I'm using I got the FLIR, sorry, I got the FLIR one for iPhone, and it works really good. So now let me stop the video 1 second, and I'm going to start a screen recording so you guys can see the files a lot better that I want to share with you, and then also that temperature capture that I got from the board of what is getting heat up or so, right? So I'm going to put you in the tripod. All right. Now you're going to be looking at me. Uh, let's start the screen recording. For the screen recording, I use, let me see it's OBS. You can look for that online. It's a free software, really, really good. So I'm going to start the recording, but let me make sure I'm in the display capture. So I'm going to start the recording now. And let's say, I mean, when I said now. Okay, so this is the files that I want to share with you. All right, so I usually uh, request the owner of the car to share the B number, and I don't think, like I said, this 7 right here is incorrect, because as soon as I start typing that number on either all data or Identifix, it just says not found. So something is not correct in there. So I replace that 7 with a 3 and it work out. And also it's MAIC Salazar Diagnostic, not Magic. So well, it's just small errors. Okay, so let me just show you. This is the diagrams that you can get on either Identifix or all data. It's not really, I mean, you can go to the color ones, but then it's no pinouts. Am I looking at something glitching? Hopefully it's happening. So that's what I want to. The reason I keeping this is as a load, so something is heating up, and I can change the values in here just to make sure that the computers are still, yeah, it went up to 163.40 on the temperature. All right, keep it going with this. I went, you know, and got most of the signals in here. I also found, I use this one most for the numbers, even though they're stamped in here, at least the bottom row 1 to 13, and then 14 to 26, and so on, right? I went also to all data, and I found the pinouts, which is really, really handy, because that's how I, was able to decipher either it's pin 5, which is also, if you see here, it goes to 23 on another connector, not really the DLC, but they call that on the wire diagrams as a connector, and it says DLC terminal 10. So I'm like, that's not for diagnostics, even though it says diagnostic test mode. So not necessary. So these are the pinouts. Going over to 13, which is it says EEPROM flashing. That's for programming and so on, and also for communication. And then again, this is how I found each and of the pins that I need for the communication. What else do I want to share with you? I think I'm seeing some flashing on the fuel pump. Hopefully it's happening. I also took some of the thermal captures. Obviously, I'm using my phone right now to record this, but this is on this computer. This is the other side of the board. So if I look at this like this, that is exactly, so that's the microprocessor here. And then we have another IC here, which gets, a little hot. Uh, the 79.6 is where this arrow is. I'll disregard this one. I was just, taking pictures on that time. Yeah, I can see some changes on that voltage. Yeah, that definitely is trying to start to cut out. So what I want to do right now is, or what you do in a case like this, is start using the thermal camera to see what is heating up, if that is a problem, which most likely it is. But so even though before I was able to see that that one is on the other side of the board, these right here, the voltage regulator, it gets very hot. This supplies a 5-volt reference. This is on this side of the board. These two current resistors get really hot compared to the rest. Not like super hot, but they were saying, like if the micro was in 94 degrees Fahrenheit, they were in 130, which is a little too high compared to what is around. So you're looking for that, something that it changes dramatically compared to the rest of the board, the temperature, and then it start to create an issue. I'm just going to leave it, and this is all I can do. leave it on, I might have to put another load. If that's the case, I might probably put one of the fan relays, which I have it on the same pinouts, and I can just put another relay, another test light, right? So this is again more of the temperature captures that I was trying to do, see how it was heating up. And at that moment when I was doing this was just before I started the video. Um, I didn't have not even a fuel pump connected, not the fuel pump relay. We can see right here, the microprocessor gets to 107. So everything is around the same temperature in here. So nothing that was abnormal, even though I wanted to capture that because I want to see like the before and the after. So yeah, I can see it is starting to do some glitching. The temperatures are still reading. The computers are still in control of the fuel pump. Let me turn that off, and I turn it off. Turn it back on, and it's on again. So nothing that I can um, condemn the computer yet. So I will keep testing it, and I'm going probably to put another load. A lot of people was asking me, it's like, how do you um, find an issue when you have, a short on a computer? Well, that is the power supply that I use. So when you know that you have well, first of all, you have to isolate where is the short. If you are, starting to remove components and the shortest is still not found, it's going to be very hard. But usually what I do is you see that fuel pump is cutting, which is a good sign. But so what I was going to say, I usually go over to one of the power rails and start to completely power up the computer. I just solder a wire on the board, and I put maybe, I don't know, maybe half an amp, and I can raise the amperage of that voltage, maybe 3 volts, 4 volts at the max, and I put, at maximum. I mean, sometimes, and I got to be honest, sometimes I put even 2 amps when it's hard to find. Sometimes, especially in boards like these, they are multi-layer. If you have a short in between the layers, it has to be seen. It's not just like, oh, it's under the layer and the board looks like this, like brand new. That I don't think is possible. In order to have a short in between the layers, you should see a decoloration in one area. The thermal camera, like that one, the FLIR one, is really really good. I recommend it 100%. Um, and then, like I said, you supply your voltage and you increase the amperage. Use the thermal camera, and then you can find the spot that is heating up. That's what I do when it's a short on the board. When it's something like this, it's decaying. The computer, it gets hot. Something is getting hotter and is open up. It can be one of these current sense resistors. It can be one of the resistors. It can be one of the capacitors. It can be a short, yeah, not a short, a crack joint in the soldering. So that's what I want to start looking for. But I wanted to share some of these testings. I know this is an old computer, but I mean, most of the new computers are a lot simpler to see what the problems are than on these old ones. Um, all right, so let me just keep going with this test. If I find something that comes up on the testing, I will let you guys know. Otherwise, again, this is for Oscar in Texas, and this is your computer, Mazda Protege 5 2003. All right, guys, so I will see you next time. Thank you so much.